Hi, everyone.
I think they should be able to see us today.
Let me make sure they can all hear me. Can everyone hear me?
I can.
Yep.
Awesome.
All right, thanks for that.
Yeah, I can hear you too.
Hello. All right, so today we'll be talking about Knative. So one thing though, I would like to apologize ahead of time for those. I'm probably going to call this native instead of Knative. I don't know who came up with the idea of putting that K right there, but somebody at Google decided to do that. And now they are jacking up my phonetics. So Knative, that's what we're talking about today. My name is Tunde, and this is...
And my name is also Tunde. I like to own up to that name.
Yeah.
I am the real Tunde. It is the fake Tunde.
All right.
So today, I'm sure a lot of you have heard a lot about Kubernetes and also heard a lot about serverless. So one way we're trying to go into talking about Knative today is to first start with, talking about serverless itself, and also we're talking about Kubernetes for people who are just joining us that have very, very little knowledge about Kubernetes, so that way we can take them along, and then we kind of jump into what we actually came here and the intent of today, which is Knative. So to get started, I would like to know if there's anyone in here that has actually worked with Knative, maybe on a beginner level or extensively. Just feel free to unmute yourself and just talk about your experience working with Knative. Anyone?
Yeah, it's fine. I'm going to be surprised if there's somebody that's using Knative in production. I'm really, really going to be surprised. My first question is going to be why? All right, so, if you have the experience, even playing around with Knative in development, have you tried it? If you've tried it before, just say hello to the rest of the team. If not, it's fine. It's fine. All right, that's why we're here.
Well, since there's no one that is willing to come on and talk about the experience working with Knative, I think I'm going to just put Tunde on the spot to actually start with talking about what serverless is, and kind of talking about serverless from the perspective of people who haven't actually worked with Kubernetes at all. I'm talking about serverless on cloud. For people who have worked with AWS or people who have worked with Azure, I'm talking about Azure functions. To talk about it coming from that background, so that we can all have a feel of what it is like working with the difference between working with serverless in cloud and working with serverless on Kubernetes. So Tunde is going to go ahead right now and talk about what serverless is.
All right, serverless. It's very easy. It means no servers. Nah. I know. Serverless from the name, right? It's serverless. The concept of serverless is very simple. The idea is very easy. The idea is to take away, right, the worries of developers, right? You have this awesome application that you want to build, and you want to become the next Facebook, the next Google. You want to become the next, Uber or something, right? It's the concept is to make sure that you don't have to worry about the back end or setup, the infrastructure setup. That is not your number one worry. That's the goal of this movement, serverless. It does not imply that there is no server. I'm very sure most of us have one way or the other dealt with, or heard of, or argued on Hacker News or somewhere about serverless. Why do they even call it serverless? Who came up with this name? Somebody needs to fire that person, right? It's Lambda. I work with Lambda most of the time, right? I work with Lambda. Some people have worked with Azure Function. I usually work with, I use the serverless framework to work with, to interact with my AWS environment, right? For those who have, there's a framework called serverless, right? For those who are familiar with it, it allows you to interact with to kind of deploy serverless across different, cloud, different environments. That's serverless. So the concept of serverless is very easy. It means you not taking away the worries of infrastructure. Infrastructure is hard. Getting it right in production is very hard. Now, taking away that worries away from, the developer, that is the goal of the movement. It has taken off. I mean, right now I see containerization and serverless going, hand to hand. And one thing that we are seeing very soon is there's going to be a convergence. That's the trend that we are going to see. And that convergence that we are going to see very soon, that is why we are here to talk about something that is talking about that convergence, which is Knative, right? You not having to worry about your infrastructure on Kubernetes. Kubernetes is hard for those who have dealt with this stuff in production. Now, you not having to worry about that part of setup deployment. For example, setting up Istio in your production environment is, for those who are using it in production, it's a day's read. You have to go read about stuff, right? So people from different companies are trying to solve that problem, but on containerization. So today we are talking about serverless, not worrying about infrastructure, not on EC2 instances, not on your on-site virtual machine, but on your Kubernetes cluster deployment. So that's my introduction of serverless. I'm going to hand over to Tunde to just give us like a quick introduction of Knative.
Well, before diving into Knative, one thing I would like to do is to actually talk about what Knative runs on, which is Kubernetes, right? A couple of people are joining us today, and wondering what is Knative, what is serverless, and Tunde, I believe Tunde just did justice to what serverless is. But now, serverless on top of Kubernetes. What is Kubernetes? What is that thing called Kubernetes? Kubernetes is actually an orchestration tool that is used to actually manage containers. Keeping it simply, keeping it very, very simple. It's an orchestration tool that is used to manage containers. So one of the things that enables us to actually run, to use serverless features on top of Kubernetes is Knative. So Knative is actually enabling us to actually run serverless or run functions as a service on top of Kubernetes. So now, I keep on stressing the word enabling. So Knative is enabling us in this case. All you need to actually run Knative is a Kubernetes cluster. So meaning that you can run this on-prem, you can run this on your bare metal, you can run it on any cloud.
So is Knative like an Istio you're running as like in that case, it's like a sidecar kind of a scenario as part of the car, or is it?
All right, so no, it's not that. So the way Knative is Knative is actually deployed on top of Kubernetes, and it has a couple of requirements before you can run Knative, which is having Kubernetes and Istio running on top of Kubernetes. And so what Knative does is it uses Istio for routing, for its routing mechanism. So it uses Istio to actually route within the cluster and also to allow ingress into the cluster, into your Kubernetes cluster in this case. So what does Knative consist of? Knative consists of it consists of custom resource definitions that are used, called the three components, which is 7, build, and eventing. They're all custom resource definitions that are used to actually, what's the word that is eluding me right now? It's used to actually, let's say, to amplify or to increase. I'm trying to look for the easiest word that passes the message across here. It's used to extend Kubernetes. So that's the whole purpose of CRDs. So we use CRDs. CRDs are a way to actual custom resource definitions. For those who don't know what CRD means, it's custom resource definitions. It's actually used to extend Kubernetes. So a company is one of the ways you can extend Kubernetes, either using aggregated API or using custom resource definitions. So in this case, each component of Kubernetes of Knative, which is 7 eventing and build, are all custom resource definitions. So the first part, which is the 7, I like to, it's not the first part, it's not like there's a first part, but the first part I will be talking about today is the 7 components. And what is the 7 components? So the 7 components is actually the compute aspect of Knative. It is where your functions run. In order to, each component can live, like the build can live on its own, but the 7, when you install 7 on top of your Kubernetes cluster, it actually installs the build, and it also installs eventing. So let's get to, so you're wondering right now, what does 7 mean? How is it different from what Kubernetes is already doing? Now let me go down into that. How is this different? Now with 7, a couple of things you can do with 7 is, say you deploy a stateless application into your cluster. One thing you can get with 7 is, once traffic or load starts hitting the URL of the application that you deployed, it automatically starts from 0, starts scaling, it scales up your application while request is hitting that application. So as long as there's continuous request to that application, your application keeps on running. At the moment, after like, there are a couple of configurations you can make that determines how long a request must have stopped before it scales down. Now, this is one of the key differences. Now in Kubernetes, you have deployments and you have deployments that manage your pods. If you scale an application on top of Kubernetes, or you start running an application on top of Kubernetes, it's always going to have a copy of that application running on top of your cluster, meaning it's consuming resources. But what if we have an application that we only need running based on need? That is where Knative comes into place. Once your application is no longer being hit, or there's no request coming to it, it scales to 0. And the moment you start receiving traffic again, the moment someone hits the URL, it comes up all by itself. So just to give a visual understanding of what this is, and I'm going to take a minute and pause to see if there's anyone that has any question right now. So I think it seems like I'm about to get in my Knative mode.
Well, my first question really was, why Knative? Because the interfaces between the various cloud providers, when you look at serverless, are not the same. So if you were to take a Knative container, take it out of AWS, and stick it on IBM's cloud, it would not work because the interface needs the event model from AWS. So it is native only to AWS. I understand that you could use Knative for like a debugging, but if you have requirements from the host environment, like event, like for AWS, where's the value in implementing this? I understand it for the cloud provider, but I don't see it for the developer outside of the direct cloud provider.
Well, so this is based off the question. This is a very, very nice question, a very interesting one, which is based off use case, right? So you're talking from a use case of AWS in this case, right? You're thinking about what is AWS capable of doing? Is AWS capable of providing events or doing, it's based off your use case. That's what you're talking about right now. Now, I could be running Knative on top of, I could be running Knative sorry about that. I could be running Knative on top of IBM's, and cloud environment, and I have a need, or maybe I've written an application that, or maybe a database, right? I want, whenever something is written to a database, I want it to trigger something to happen. That is a use case that actually has nothing to do with any of the services that are being provided by IBM's cloud. So this response is from my understanding of your question, and does that actually help?
Well, in sort of a way, but it's the interoperability of Knative, because the fact that we're talking about serverless and that the interfaces between the various cloud providers are not the same, it makes it so that it's good for the cloud provider as a good use case to run Knative for themselves, and therefore they can spin up as many instances of the serverless function that has been created, and it's a good thing for them. Yes, but interoperability between different serverless environments that are not homogeneous to each other, that I gave an example between the event model in AWS against what is IBM's, is the fact that that event model interface for that serverless function doesn't exist in IBM's environment. Therefore, it's not interoperable if I were to lift that container and stick it on IBM. That's all I'm saying. And therefore, I'm trying to understand a better use case for this beyond just the local cloud provider.
Oh, okay. So for one thing, I think Tunde is about to chip in into this, but before, I think I understand your question a little bit more now. So the thing is, every single thing you're running on top of Knative, think about it as living inside of the Kubernetes block. So isolated away from the cloud environment. Don't think about a cloud environment right now. What is happening on top with Knative is existing within the Kubernetes box, within your Kubernetes cluster. It depends on every single thing that you have installed on top of your Kubernetes cluster. So this has nothing to do with what is outside of your Kubernetes cluster, except if you have like an API that, you've written code to actually, interact with on top of maybe any of the AWS services. So if you're running it on IBM service, or if you're running on Oracle Cloud or any other cloud, it would depend on what you're doing on top of that cloud environment. It would depend on your use case. So,
all right, let me chip in that. So, first of all, the person I'm talking to, Peter, right? I can see you've gone through the documentation already, right?
Yes, yes, thank you.
So I think I know what you're talking about. You're talking about the eventing, right? Now, you're talking about the fact that you are trying to build an application, right? And you want the application to be triggered by an external event. Now, there's a new project called cloudevent.io. Go to that website. Because right now, I get what you're trying to say. You build an application on AWS that interact with an event from AWS, right? Now, you move that application to IBM. You are trying to interact with the same events. But because IBM developers are different from AWS developer, the format of the events are going to be different, which is going to make your application very cloud specific. But there's this project called cloudevent.io that is in progress right now. Very soon, I expect the project to join CNCF. The goal is to unify the event interface across all the cloud providers. So if AWS is sending out an event, it's going to have the same format, although different data. Go to that website, cloudevent.io. Their goal is to make sure, because the success of Knative interoperability that you mentioned is dependent on the ability to have coherent event.
And thank you. You hit my question directly on the head. Thank you.
Okay. Yeah. All right. So I'm going to hand over to Tunde, because event is very, very interesting. It's about to go into the deep part. All right. So,
are you sure you want me to go deep into events?
Yeah.
All right. But yeah. So, does anyone have any other questions besides Peter?
I have one.
Great.
Why Knative, or what's the trade-off of Knative versus the other functions?
Well,
Kubeless, OpenFast.
Well, so I can start with how the project was come about at first, right? So Knative is so I think one thing we were trying to mention at the beginning was actually who were people that contributed to this project, Knative. So this is a project that actually started by Google. It's been supported by Red Hat, IBM, Pivotal, and SAP. So a lot of big companies are actually invested a lot in this project. In comparison to OpenFast and Kubernetes and the other functional service out there, when Google is involved in a project, and IBM, Pivotal, you know, this is about to get really big. And then one other thing is, picking from the name Knative, it's kind of Kubernetes native. That's how some people think about it. So it is native to Kubernetes. It brings in a couple of other tools to actually make Knative and make Kubernetes kind of like Voltron, right? It brings the building part into it. It brings the eventing part, and it brings the serving part. And it kind of like, it's Kubernetes on steroid now. And it's now all about, you know, what can't I do with Kubernetes? There's a lot of use cases out there with the components that come with it. So, and also another trend that I've seen out there to think that this is very, you know, this is different from every other thing that is out there is most of these other function of the service that is running out there, they're now running on top of Knative. So Kubernetes is now working to run on top of Knative. Reef is doing the same thing also. A couple of all these other serverless projects are actually doing that. So I'm definitely sure Knative is here to stay. So moving along, you know, we've talked about what 7 is, and so we can move this slide. So the parts of 7, I really like this slide because it does a lot of justice to what I'm about to talk about. And this is something I got from actually the Github for Knative. So a couple of parts to what 7 is it has something called service.
Can you share the desktop again? Could you share the desktop again?
Oh, sorry about that.
Oh, the desktop is not being shared right now. Very bad presenter. All right, so let me share my desktop. Oh, yeah, actually. All right. Share my screen. All right. Let me share my desktop. Sorry about this.
Thank you.
Can you send us the slides? Oh, yes, yes. I can send it. I can send you a slide. This is,
Can everyone see the slide now?
all right.
Yes.
Oh, awesome.
All right.
All right, so this was the awesome slide I was talking about that has what's the definition for what service is, right? So, you know, I mentioned that there was a service part, and there is the eventing, and there is build. So in 7, a couple of things are needed to actually get an application to run in 7, which is the service, the very easy way to understand this is, I'm going to go back to this. I kind of like this Voltron concept, right? So there's routes, there's revision, and configuration. Route, revision, and configuration. Think about all of them. Look at this, this drawing right here. So the service, the service is a kind of like, it's a kind in Kubernetes that when you deploy the service, it creates a route and creates the configuration. For every single time you modify a configuration, a new revision is created. And a revision is kind of like a point in time snapshot of your current configuration. Now think of these revisions are all immutable. So what's the purpose of these revisions we have right here? Each revision, so let's say we deploy a service definition on top of our cluster right now. It generates a configuration. That configuration, every single time it generates a configuration, it generates a revision. And that revision is just a point in time copy of a configuration. And the purpose of this is, so say for instance, I have a software developer called Tunde, and it was working. I'm not talking about my own Tunde, but it messes up, and you know, we have to make a correction. And we need to roll back. One thing we can do is we can make modifications to our configuration and point it to the new change. And then once we make that configuration, we have a new revision. And then one thing we realized, well, Tunde is not all that a bad developer. He didn't make any mistake. I just read the code wrong. And then we have to go back to what we were working on, which was the point in time, the previous one. We can roll back to the previous revision. So how does it point to each of these revisions? It uses the istio route to actually route to each of these revisions. And then we also have something called an activator, or some people refer to it as actuator. But the official term in Knative is activator, which is in charge of actually pointing to the right revision. So one thing is we have to think about, is the revision ready? There's a status for a revision. Is this revision ready? Is it ready to start serving traffic? So the activator is in charge of that. That it's in charge of, you know, I'm going to point to this revision because this revision is ready. And it's also in charge of when the revision, let's say there's nothing eating a revision anymore. It stops everything that is going to that revision, and you know, it scales to 0. So that is an easy way to actually think about what is going on here. But now, let's take away the service part. We can deploy a configuration and deploy a route, and we'll get our application functioning. Because we know now that if we create a configuration, a new revision is created. And once a revision is created, we need a route to actually point to that revision, right? So we can generate this one, which is the configuration, and the route ourselves, and point it to a revision. Or we can go with the easiest way, which is actually just defining a service. And inside of that service, we have a configuration template. And once we deploy that service, it generates the route and also the revision. So this definitions right here, like it says, you know, service manages the whole life cycle of your workload. Configuration maintains the desired state of your deployment. And revision is just a point in time snapshot. Our route, it maps, you know, your networks within the cluster and also allows ingress into the cluster. So next thing I would like to show is a couple of the manifest. So this is the service manifest I was talking about. How is this different from the normal manifest you would see in Kubernetes? You know, how is it different from a deployment or a pod manifest? One thing is that you look at the API version, this is straight giveaway that is a custom resource definition. If you've seen a lot of custom resource definition, you'll kind of see this format, right? And we have something, if you look below if you look at the spec, we have something called run latest. And what run latest is saying here is whenever we create a service, what it's going to do is it's only going to use the latest revision. So let's say we make a modification to this current manifest right here. The new revision that is being generated is what is going to be pointing to. There's also another object here that you can put in here called pinned. If you use the pinned, what that allows you to do is once you make modifications, it sticks to the original revision. It doesn't automatically change to the new one. And you can see benefits. You have a question?
Yeah. Where are these revisions managed?
No. So it's actually all on the Kubernetes cluster. So once you deploy it, and I'm going to show you during the demo, once you deploy it, it actually creates a revision, and you can run kubectl get revisions, and it shows you how many revisions you have.
I can go back to previous revision.
runs the interface around that. You don't run the latest. Okay. Specific version. If you want a specific version, so all you just need to do is just switch. Oh, I think I missed the question right now. So if you want to run a specific version now, you have different. You use the route. You use the route to point to the specific revision you want to point to.
I'm saying is it, you don't have run latest. Which one does it use?
Oh, so if it's not run latest, it's either pinned. So if you use pinned, it's going to be pinned to the one that was deployed first in the manifest. So in this case, if this was pinned and we made a change to what was containerized here, it's still going to be pointing to this one.
I see the demo.
Yes. So, I'm sorry?
Example of the YAML
For the pinned? Let me see if I have that here. I mean, we can look at that during the demo.
Yeah, I can put it up.
So now this is service manifest in its simplest form. So we have a revision template that contains the container and the container image that we're going to be running and the configuration. Once you deploy this manifest it creates a configuration and it also creates a revision and a route. And that route points to a particular revision. So you go to the next slide. Now this is a more this service contains more. Right now it contains the build component also. So one thing that's very interesting about serving in this whole Knative thing is, think about this process right here. This is a perfect example. So your developer writes a code. Typically right now, if you're running Kubernetes, you write code, you containerize the application, you have a Docker file, you build your application, and then you put it on top of, you Dockerize it, and then you run it on top of Kubernetes, right? But what if we had a solution whereby all the developer needs to do is just push to the repo? They don't need to know what's going on top of Kubernetes. And also update the Docker file. That's all they need to do on their repo. Once that is done, we just have this manifest here that points to the Git URL. So we're using something called a source. There are different sources that you can use. But in this case, it's using Git, right? It points to the URL and goes in and find the code or what you're planning to build. And it goes ahead and builds that and then runs it after building it. And then here, it's showing the kind of image that is using to actually build, what is using to build the Docker file. So yeah, it's using the build path in this case, right? But the official building tool that is being used in Knative is Canonical, because I think Canonical is one of the most matured building tools out there. Other building tools or examples of something like this is the S2I by Red Hat, which is source to image. I know a lot of people that have worked with Red Hat might have heard about it. There are also some other interesting projects like IMG, but it's still growing. It hasn't really matured yet. But this is another really cool thing about about service.
Yeah, there's an example. We have an example.
Okay.
Yeah. So no, we did not we didn't think people were going to be interested in the paying version, right? So that wasn't. So we didn't think the people were going to be interested in the paying version. So let me just quickly pin up an example on GitHub to show you what the paying version is going to look like, right? You don't want application to be deployed, boom, into production. You want to stick it to a point in time, right? That's what you're trying to do. All right. So let me quickly exit. So I pulled up this example on So I'm putting up the example on GitHub to show you. All right, native pin. All right. So what I put up native, I put up serving. So it looks like people are really interested in the pin version. So this is an example for those who are not. All right. The pin. Look at the pin version, right?
There you go.
Look at the pin version. This is a pin version. It's instead of using the latest route strategy, you simply pin it to a particular revision, right? For example, when you release your application of version 1, version 2, version 3, those are different revisions. But you want to pin it to just version 2. You don't want to pin it to version 3, version 4. Everything stays at 2 regardless of our deployment. This is how you do it. And regardless of if you keep deploying, although your service is going to be updated, but the routes are always going to be going to that particular revision until you change the strategy to latest, if you want to, right? Or update the pin revision name. So that's it. But yeah, so
did that help?
Yeah. What was the build tool you mentioned?
Kaniko. It's Kaniko. Kaniko. I think Tune can show that also.
yeah,
So can you show? I'm sorry. So all it does is actually build the Docker, takes your Docker file and builds it.
yeah.
And then you can use that Docker file that has been built to run as containers in your environment.
Or builds the container images.
Yes.
Yeah. Now, the main advantage about Kaniko is that the reason why Google introduced Kaniko is because Docker, for you to run Docker in your environment, you need elevated privileges, right? And some production environment cannot afford to have a container with elevated privilege. That is why sometimes when you try to build a container on Kaniko, it fails because it requests for elevated, and Kaniko doesn't do that. The goal of Kaniko is to make sure anytime you build the application, it only has the privilege of the user space, no elevated privilege. If you request for elevated privilege, you die. That's the strategy. So people use it for security reasons.
That's a very huge advantage to the other tools that we have out there.
Very big advantage.
So I think for 7, this is what I have on the slide before the demo. But before going into the demo, I would like to go through the other components. So 7 is just 1 out of 3 components of Knative.
All right.
So let's see the build. Let's see the interesting thing about what this build is.
All right. So this is new, guys. This is new. It's boring, but I mean, think of Kubernetes in 2014-15. It's very boring. Think about it that way. Now the build, I'm about to bore you before that. The build part. Now the 7 itself, for those that are going to use 7, right? We have the 7 Knative. We have the 7 components, the build component, the inventing component. Now, some people are like, I don't really need 7. I'm not going to use this in my production. But people have started using build in their production environment. So what is build? Build simply means GitHub plus Kubernetes for Knative. It allows you to build application from a Git repo, right? So build, hey, I have this Git repo on my GitHub account, and right, I have to clone it down to my user, my laptop, right? I have to clone it down. I have to run Docker build, tag it. You have to send it out, those steps. No, you don't have to do that. Knative, the build component is going to do that for you. Now, the advantage of Knative is that it uses a primitive object, CRD, to build your application, right? Now, build, I'm going to show a pre-recorded demo because I wanted to show a demo of a build. We are still going to see a demo of serving, but that's like the sweet part, right? It's the interesting one. All right, so let me show you like a very small demo of this guy, build. Because, oh, sure, I keep. All right, so let me show you a very small demo. All right, so quick time. All right, so does anyone have a question right now? All right, all right. I'm about to show you a very, very interesting demo of Build that I recorded last night while I was very, very sleepy. Now, the build is very, I have this application. You go to my GitHub account, then you won't see this application because I don't have private GitHub account. So you will see this application, and I'm trying to build this application using Knative. I want Knative to point at this my repo, clone it down, build the image, and send it over to my Docker account. That's what I want. Now the first part, let me show you. This is my GitHub repo, right? Now that is my Docker repo, right? As you can see. Now the application was built 23 minutes. The last build was 23 minutes ago. Now this is my build template. If you look at the build my build template or my build YAML specification, I'm creating a service account. I'm not going to show you a service account because it contains my GitHub credentials, right? But you can figure that out. It's very easy to figure out. The source, I'm specifying where the files are located. As you can see, the files are located in my suite app GitHub repo. That is where the files are located. Now, the steps. I want to build it, but who is going to build it? Who will build this application? That is that guy, this guy right here. This guy right here is the guy that is going to build the application, Kaneko. That's the work of the builder. Now, the Docker file. Okay, the argument I'm passing in. Okay, after I clone this repo, how do I find the Docker file? Where is it located? That's the argument I'm passing in to Kaneko. Okay, I know the location of the Docker file. Where do I push this to? That's the question of the destination. I want it to push it to Blackwell. Sorry about my username. My Twitter app. So that is where I want it to push it out to. Now let me run this. All right, so, all right, okay. All right, so that's the GitHub repo, and that's the executor, and that's the destination. All right, so the next step is let's go ahead and run this. Okay, now that's my terminal. Let me go ahead and run this. I have my cluster set up on GKE. I'm going to advise you, if you are starting this, if you want to play around with this, okay, I've created the build. All right, I've created the build. Now, that is my build object right there. This is my build object. As you can see, it contains a bunch of stuff that you don't need to worry about at this stage. But for a production environment, of course, you would like to go into details. For example, you can see the service account. You can see the source. You can see the steps. Now, that is the build object. Let's look at the pod that is actually doing the build. Remember, Knative is using Kubernetes. It's not doing anything by itself. All right, so as you can see, it's still the same thing like in my YAML file. Now, the next thing that we're going to see, come on, move on. All right, that is the pod that was created to build itself, to do the building. All right, let's look at, I just exported the name of the pod. Don't worry about that part. Now, this is the pod itself. Now, this is the pod itself. This is the interesting part. The first part of the pod build is called build step credential initializer. Remember, I passed in a service account. It contains my Docker credentials, which I'm probably not going to show you guys, but I'm not going to show you guys, right? So what it does is, it says, here is a credential to log into Docker. You can see this annotation. It means that credentials can be used to log into Docker. The next step means okay, I have the credentials. It's been mounted into the image. Now, where is the file I'm trying to build? The next step, called build step git source, is the guy that pulls down your Git repo. Okay, I'm done. Now, the next step, which is where the build itself takes place. That is the main step, the one that Kaneko is responsible for. It says, okay, I have the Git repo, I have the GitHub repo, I have the credentials that I need. Let's do this. The guy that does that is a Kaneko, right? Okay, he knows where the file is located, as you can see from the ads. He knows the destination that it's supposed to go to. Boom. It pushes it, it runs it. All right. I'm going to show you the logs from this. All right. I didn't want to show this live because most of the time my live demo goes wrong. So, all right, so that's the point. Let's look at the logs. Let's look at the logs. What happened during the build? Okay, yeah, that is it. This is what happened during the build. As you can see, it's actually building it. It's using what? The Kaneko, right? The builder. It's copying the file the same way you do your Docker build. It's looking at it, exporting forth, right? It's everything that you need to do, it's doing it. And it's pushing it out to GitHub. Remember, my last build was 23 minutes ago, but after running this, if I go back, come on. All right, if I reload the page, the last a minute ago. So it was actually pushed to my GitHub repo. Most people don't really care about Knative rather, at this stage, because it's still an alpha project for, production serverless functionality. But a lot of people are using it for this purpose, to build the application on Kubernetes. Which? It's the image that was built. Yeah. So instead of me having to write Docker build stuff like that, it built the image and pushed it out to Docker, my Docker account. And that image was run in user space. It's not a privileged image. So you can say it's safe to run in the production environment, unlike a Docker image. A Docker image is very dangerous if someone gets their hands on it in the production environment. All right, so that's the build. Sorry for boring you guys. So that's the build. All right, so the next thing I'm going to talk about is the build template. Why do we need the build template if we have the build? Why? Why do we need that? All right, so I'm going to, I wish we have like this double screen here. I wish we have double screen here, guys. So that's the builder. All right, the build template. Remember, if you look at my build, I specified, the Docker file. I specified the image. I specified everything. If you compare two of them, look at this one and look at this one. That's the builder. Look at the build itself. Look at the build. All right. The build has too much information, right? Now, the build template is a way to save you stress. It's a way to just save you stress in the build template, for example, I'm using the Kaneko build template. This is a Kaneko build template. What it's saying is, hey, just pass me the Docker file argument, pass me the image argument, and just leave the rest to me. So if you want to do a build, all you need to do is mention my name as your build template, pass me the argument of the Docker file location, pass me the argument of destination. I'm going to take care of the rest. That is what a build template. So you are going to be using this more than the previous manifest, because right? So you can switch out your build template. Let's say I use Knative to build my Git repo. I can actually switch it out for a new builder, and the new, provided they accept the same argument. The argument can remain the same if they accept this. Yeah. Which one? Yeah. This one? No, I think I can show you a sample of my service account.
No, that's fine.
And I have one for demo. I think I sanitized it. Jeez, this is very risky. All right, I think I sanitized it. All right, so build. All right, so, Docker auth demo. All right, guys. All right, I think, yeah, there's one I sanitized. Yes. So it has a secret, right? Your username, your password. I'm very sure as time goes on, this is going to change. For example, because your username and password should not be in the manifest like this. It should not. But remember, this project is alpha. I mean, today on the Slack project, I still like, commented, because there's a Slack group for the Knative. Please go and join it. It's a very good community, very friendly. I still commented on an issue whereby my eventing was not working. I should be working. So the project is still in a very, very early stage, right? But one thing that we've realized is when something is backed by Google, as Tunde said, backed by even Red Hat, Pivotal, these guys are not backing down. They will, achieve what is going to be the standard. They will do that. There's already a talk about Joe Beda. For those who are in Kubernetes community, Joe Beda gave a presentation on this. So we have people, a lot of, name behind it. Right. All right. So
Joe Beda is 1 out of 3 founders of Kubernetes.
yes. Yeah, Joe Beda. For those who don't know, he's a very cool guy. A soft spoken. Very, very, yeah. All right. So let me bore you with more details about Knative. Let's talk about eventing. Although I'm not going to be showing demo for eventing today, sorry about that, because of the reason of what I mentioned earlier. What is eventing? I'm going to.
So I was thinking before jumping into eventing. Sorry for cutting.
No.
But I was thinking, so today went through a couple of things and we build. We talked about builder, and build templates. Does anyone have any question about, the differences on, like, would you like anything to be clarified? Does anybody have any question about how this is different from the solutions that have been provided by other functions?
Why we need build templates? To avoid repetition. Yeah, it's just to make sure something reusable, right? Exactly. Also for consistency, also because if I'm trying to specify the builder, the Docker file, the this, I'm likely to make a mistake. But just like you said, for consistency, if I put in the wrong argument, the build template is going to reject it. Like, hey, you did something wrong.
I think someone has a question.
Oh.
With the build template, is it set up in such a way where you have overrides, like there's higher environments, and you have a default things build template, and you want to override things for particular environments?
Oh, yeah.
That you can do,
Yeah. All right. So, there's an awesome question right here. So someone is asking, is the build template set up in such a way that it's allowed override? The way, for those who work with Elm, the way that you have variables defined for your prod, your stage, you want different kind of template, different kind of parameter passed in. Yeah, right now, sorry, we are still in that early phase.
That's great. That's great. You know what you can do? That could be something that you can contribute to the project for.
Please and please go and join the project. Even if you don't, you're not going to contribute something, just click that stop. It makes it more, people know about the project and it grows faster. Look at Kubernetes right now, 40,000 people. Jesus, right? So that brings, solid attention to your project, and development goes faster. You can post that on their GitHub page. Please do that. Please. Does anyone have any question down there, in California, New York, please? Does anyone have any question? Colorado.
Yes, just one question maybe.
Okay.
In relation to, so far, the build templates, I mean, those CRDs, those objects, are not specific to serverless, right? Meaning that we could potentially build our own containers using those build template CRDs. Is this correct?
Mm-hmm. Yes. You don't, for those of us who don't care about serverless right now, yes, we have some of us who don't care about serverless. We just want to I just want to build I care about Kubernetes. I use Kubernetes, but I love this functionality. You can use it in your environment. In fact, you can actually install the build object itself without install serving. There's an option for you to install build by itself without installing serving on your Kubernetes cluster. Hey, I don't care about serving. I just want to use the build. You can go ahead and do that. Yeah, thank you very much for that question.
Another question.
Okay, yeah, we're listening.
Yeah, this is more of a generic question. The question is more, at what point do you feel the need to start using Kubernetes? Does it have anything to do with the number of servers you need to maintain?
That's a very good question, right? Now, that question, oh, sorry about that. The question is, at what point do you feel the need to start using Kubernetes cluster? Can someone I would like this to be like community discussion. Can someone jump in for those who use Kubernetes in their environment? Just, jump in and, into that question. I would like this to be a conversation. At what point do you feel the need to start using Kubernetes cluster?
You have more than you can manage.
Yeah.
You have more containers. Your application is 3 containers.
Yes. Thank you. Someone brought a very important point. If you get to a point whereby you have more than container, right, then you can manage. He gave an example. For those who are using who have 3 containers, you don't need to install a Kubernetes deployment to manage that. But once you start getting to the point oh my God, you have to wake up in the middle of the night to restart a container, then you need to start thinking about Kubernetes. You start, for those who are running 30, 40 containers, trust me, I don't know, you might be like a magic, SRE or DevOps engineer, but managing 40 containers is probably going to make you just wake up in the middle of the night and I'm done with this, right? So use that point, you can use Kubernetes. I think he wants to say something also.
I was going to say, I come to use it, and it was kind of a recent migration toward it.
Okay.
And one of the advantages I see is it kind of helps simplify the job for DevOps, and then also give developers a little more control over the environment.
Oh.
Right? Developers get to specify all the dependencies, the operating system, the locales, all kinds of anything, exactly how you want the environment set up to specify it. And just take the image and they provision it based on resources that you specify. Then I think another thing is also from a cost perspective, right? You have one cluster that you manage and look at costs and resources.
Oh, yeah. So someone brought up a point about, first of all, the ease of interaction between developers and operation. So Kubernetes give you that. And also from cost perspective, right? Kubernetes can help you to scale down your resources. For example, those who are running Kubernetes, your production environment, I know some of us use what we call cluster autoscaler. For those in cloud, that helps you scale up your instances if pods is unschedulable or scaled down if pods are not being used. So cost perspective can also help in making that decision. All right, thank you very much. I think just move on. All right, so let me go to the last part, eventing. Eventing, now there's this project has a goal right now. And the goal is, I think, it's my personal belief, this is going to be one of the most important parts of Knative, the eventing. It's very primitive right now, right? It's very primitive right now. They support a couple of events, right? But I think this is going to be the biggest advantage of Knative above every other environment. The goal is they are trying to make sure that the eventing component, what is eventing in the first place? Eventing simply refers to the fact that I want external event to trigger action in my Kubernetes cluster. My question to you is, how do you achieve that in your current Kubernetes cluster? External events, something, for those in AWS, a DynamoDB changes. How does that event get into your Kubernetes cluster? As far as I know right now, I don't know. Has anyone thought about that? If something changes in your database, you want an action to take place in your Kubernetes cluster. You want a job to be run. You want a pod to do something. Right. This is where eventing comes in. Ability for action outside your Kubernetes cluster, within your Kubernetes cluster, to trigger, to bring about a change, to make something happen. That is eventing. It's very primitive, but I can tell you 1 year from now, you're probably going to read about it, about somebody using it. Because IBM is on this case. I know Amazon is probably not going to join it anytime because of this is a competitor to Lambda. I'm thinking, Amazon is very, very, I don't know. And it's Google anyway. But I think Red Hat is on it. And Red Hat, IBM, like you said, Google is on it. This thing is, I believe, is one of the most important parts. Ability for external events. Ability for, something that happens in maybe, I don't know, Jenkins, to trigger change in your Kubernetes cluster. That is the point of eventing. And it supports a couple of, sorry about that. Now, these are the components of eventing. Now, let me talk about sources. Sources are the external system that brings about events. For example, a type of event is what we call GitHub event. For those who are familiar with the GitOps movement, somebody merges to a branch, for example, the master branch. You want that event source to, how do I say this, to cause a redeployment in your Kubernetes cluster. You want that event source, that merge, to actually cause messages to be posted to your Slack. You want that thing to cause, I don't know, to trigger some order, to increase the number of pods running in your cluster. Those are event sources. Right now, they support 3 main event sources. K8 event within the cluster, that's an event source. Events taking place in the Kubernetes cluster, that is an event source. GitHub event, and based on I actually went through the code. Right now, they only support pull request event type. What do I mean by that? GitHub is an event source, right? But each event source has different event type. A lot of events come out of GitHub. A lot of action takes place on GitHub. You merge code, you push code, right? You do different kind of thing. So pull request is a kind of like event type of an event source. So pull request is the only event type of the GitHub event source that is supported right now. But I think others are going to join in as time goes on. And that's what I believe, or that's what I'm hoping. Now let's talk about bosses. Bosses. You can think of bosses as, to simplify things, think of bosses. For those who are not familiar, it's a very tricky concept. Think of bosses as Kafka. That's the best way I can describe bosses. Remember, for those who use Kafka in their environment, the point of Kafka is to hold events, right?
Where's Kafka?
Oh, Kafka. All right. Now, for
That's all correct.
it's just ask me like, what is Kafka? All right, so I'm going to explain Kafka for those who are not familiar in a very, very layman time. Or I'm going to use a use case to explain Kafka. Now, let's say I used to work for a company that does a lot of like recommendation system. Events come in at the speed of light sometimes. That's how I feel like. Now, your system does not have the ability to respond to those events or to process those events immediately. What does it do? Are we going to lose those events? Are we going to discard them? No. We put them somewhere that in a queue. Thank you. In a queue. Think of Kafka as a queue that you can pull back like, hey, okay, I'm ready for this event. I'm ready to process this event right now. Let me grab it. So think of boss in that aspect. Those events are coming in. They're going into the boss. Think of boss as the queue, as a Kafka queue. For those who are in Kafka environments. Now, on the boss, we have a couple of components. We call it channel. Think of channel as your TV station. Think of channel as your TV station, right? So in a channel, right, you subscribe to it. So a boss has a channel that delivers an event, and you have a subscription that says, I want this event to be delivered to me. So for example, I can be a service. I subscribe to a target in a boss that, hey, I want this event to be delivered to me. Don't worry about the full details. It's still kind of like, exactly. That is one of the event sources, the pub sub. The pub sub is one of the event sources right now that is supported by Google, right? That is supported. I believe other event sources, I hope very soon, AWS event sources are going to be supported. I know one thing about AWS is once they see that something catches on, they also try to get involved with the development community. So I really hope so that they also join this because I work with AWS a lot. I know Google is going to support it once the dev guys produce it. And also we have IBM and I'm very sure as time goes on, we'll start seeing event sources for bare metals. So now, all right, the last part is called flow. Sorry, the last part is called flow. What is flow? For those, somebody is going to have a question right now. How do I build all these components? Why do I need to build all these components? How do I build all this? Don't worry about it. You don't have to do them. Yeah, it's part of the eventing. Yeah, if you look at the diagram, it's actually part of the eventing. Right.
We're up to 4 parts.
Oh, yes. Sorry about that. So the flow, think of the flow as let me explain it this way. For those in Kubernetes environment, remember, you create a deployment. A deployment creates a pod for you, right? Think of flow in that way. You create a flow creates what? It creates the event, all its event type, the channel, the subscription, right? It doesn't create the bus for you, you have to supply the bus. But the channel, the subscription, all those CRD, those objects are going to be created for you. You as a person, you know channels is there, you know that subscription is there, but you don't have to worry about it. Just create a flow, and the flow is going to take care of it for you. So this is a flow right there.
Just to piggyback off what Tunde just said, I like to think about this as a very key part of eventing because it defines a lot. You know, it's telling you what triggers, it's telling you the action of things. Also, it's mentioning the service. There are a lot of interesting things that actually make eventing happen. So think about it more or less as who is in charge, who is actually doing all the control. Mm-hmm. It's like just from the words, like it's doing the distribution, saying, okay, yeah, this is what is doing the triggering, and this is the action that is happening.
Yeah, exactly. So think of it as a big guy that just take over the job from you and help you provision the rest of everything you need. Because to be honest, I don't really care about channels. I just want my event to get to where they need to be. That's all I care about. So that's flow right now. And I think we are about out of time. So,
well, one thing is, consider this a bonus. I was planning on doing and we will be doing a live demo. Today I'm feeling good. The flight gods were with me, but I think the demo gods are going to be with me today. But yeah, so one thing is, we were trying to do a demo of, I think we should be able to do that, right?
Yeah, we can easily do.
Yeah.
Yeah, sure. Oh, sorry. Oh,
sorry about that. Sorry about that.
Sometimes I forget that this is a presentation. Like we have people with questions. Sorry about that. So.
Okay, sure. I have a question.
Oh.
So the earlier question about the portability of Kubernetes sounds like eventing.
Yes, event. Oh yeah, I think someone has. Okay, let me quickly answer this question.
Oh.
All right. No, let me. Okay, so he asked a question about the question earlier about interoperability of the eventing. He mentioned the fact that it relates with this section. Like it looks like eventing already answered that question, already took care of it, right?
That we moved from AWS to IBM, external events specific to AWS. It would be eventing that we like move that Kubernetes to the service provider. Instead of the source, the account to the external. I'm assuming it's in the future.
Yeah, all right. So I think we can use the speaker right now. Okay, I think I use it. So I think where is the speaker? Oh, try it. All right. Can you hear me right now? Is it loud? All right, guys. So I think people also want to hear.
My question was whether eventing addressed the earlier point about dependency on Amazon and then that is to IBM and there are any differences. My question was whether eventing could eventually, I'm assuming there were mature set of sources that
All right. Thank you very much. So now you get the question. Now the question is, will they? I mean, right now the project is. I love to repeat that word. It's in alpha phase, right? We cannot say this is what is going to happen. But one thing is the eventing, just like you said, I believe that question is going to be asked. For example, you develop an application on AWS, and you got a call from your CTO. Hey, GCP offered us this discount. I want all the Kubernetes cluster on GCP right now. How do you undo the possibility of the expected cloud event? I believe that question is going to be answered down the line by somebody, I hope very well, and because it's very, very important. But right now, there is no existing object that takes care of that.
But I presume there would be community activity.
Yeah, I see that happening I see that happening very, very well. I see that happening very, very well, that the pressure is going to come from the marketing guys. Like, hey, okay, you're trying to sell this to, I don't know, you're trying to sell this to who? one big company, but we are on this environment, right? So please, we need something to support this. I believe it's going to come from the community. She has a question also.
All right. I can answer that question. All so right. the one for the build is actually for the registry. So that, right?
Yeah.
That's actually for the registry. So you can pull the images. So it's kind of like when you're trying to use what we call in-house registry. So you have to create your own registry to access them. So that's kind of that's the same case with the huge separated accounts. So.
Yeah. All right. Does anybody have question online? Hello? Does anyone have any question online?
Yeah. So this is Aaron. Thank you so much for this whole presentation. It's really awesome. My question is, the existing serverless infrastructure is obviously very Lambda AWS based. Yeah. How do you see the coexistence? Do you see people in essence planning on any new serverless architectures to put them really in like a holding cell separate than the Lambda? So you almost treat, like the Lambda is, I'm going to call it legacy serverless, but, somewhat. I mean, how do you see that? Because when you're trying to design, you're trying to make choices on what to do, it's hard sometimes to view all these other new specs or approaches, OpenWhisk, et cetera. And all right, what should we do? Write 3 times and run once, write once and run 3 times. Just it's hard to figure out what the pattern should be. Does that make sense? And it's a little convoluted.
Totally makes sense. So the question is like, it's talking about the comparison between AWS Lambda, right? It's very like, VM, EC2 instance kind of based compared to these guys. Now, as a company, how do you choose between this one and the existing, Lambda ecosystem, or what you refer to legacy ecosystem? What do you put in consideration in making your decision? Does anyone want to like chime in or something?
I mean, one thing I can think about. Let me jump at this. One thing that I know right off the top of my head is, as more competitions come in the cloud, and also for the serverless applications, you don't want AWS keep on extorting you for Lambda service. You want some kind of competition, and also you don't want to be fixed to a particular application. Lambda is only running on top of AWS. You want something whereby if you're migrating your Kubernetes cluster away from AWS, you want to be able to move it all the way to Azure. You want to be able to move it up to GCP or whatever cloud, becomes the new, top guy in the cloud native world. That is one reason why a lot of people might shift or make the decision on going with Knative. And now one other thing with Knative is, this is an open source project. This is something whereby you can easily go to the Knative community and find out, who's having the same issue that I'm having. The demand for solution is something that an individual outside can just contribute to the project itself. Unlike with AWS, you're waiting on AWS to actually provide, response to what customers are requiring. So that is where.
I mean, you bring up some great points. I mean, the thing that this reminds me of, and I don't know how many of you are old enough to having gone through this, but when Oracle in the 90s and, really kind of laid down a gauntlet with PL SQL, it really kind of substantially segregated the There used to be a standard called SQL 92, and there's like these SQL wars in the 90s. Let's put it that way. And Lambda reminds me of kind of that same thing. It's almost like a optimized lingua franca baked into AWS that doesn't really have, there's no structural portability because of its innate DNA. And I don't know if that makes sense as an analogy to anyone, but that's kind of what it reminds me of.
And also, I want to say this, for those of us, what I think is open source is going to eat out everything. There's this company I think in California with a bunch of money backed that just want to invest in open source projects. All they want to do is just put money on open source projects. Right now, they are getting a lot of backing. And Lambda, I see Lambda is going to be very powerful. It's the #1 guy right now. But I see us going the way of ECS versus Kubernetes. AWS provided ECS for them to, attract container community. But ECS could not stand Kubernetes. Docker Swarm gave in to Kubernetes. So I see open source with the backing of people like Google, other 5 companies, Red Hat, Pivotal, IBM, a project of that taking away a significant, how do I say this, demographic from, so it's probably going to, it might not take out other players, but
Is it just me, or did anybody lose connection?
Connection lost. I don't know. I cannot hear him.
Yeah, I can't. I think they got disconnected.
While we're waiting for them, let me throw a question out to you guys. Hopefully, somebody can help me out here.
Oh, good. They're back.
All right, thank you.
all right. So do we have any other question?
Yes, I do have a question, and this is more outside of the advanced world. This is more rudimentary. So what's going on is that we're always fighting a war between should our code reside inside a container and we push the container all the way to production, or should the code actually live in the repository and stay on the host and just get mounted to the containers, and only the code moves along the pipeline? Again, I'm just looking for discussion and best practices.
All right, so the question is, so how do we go about the practice of your data packaging? Do you, the practice of packaging your data inside the container versus the trend of allowing your data to be on the host, mounted on the host, for example, for those on cloud, some kind of NFS on the host itself, then mounted into the container. So what you guys thought about it? What do you guys think about it? Does anyone want to jump in online to chip in on that?
And I mean, this is Aaron again. My sense is just how mature the operating environment is, and also the industry it's in. If it's a highly regulated, very mature organization, you're going to have quite a few segregation of duties and ultimately segregation of the operating environments, meaning there's a production control team and a staged to a production test team that's completely different than the traditional dev non-production type operations organizations. So your tool chain life cycle is going to be very different. And what I've seen is that you're getting these awesome killer tool chains that the dev non-production side are leveraging, but the production operations teams are not really leveraging those for, you know, all kinds of reasons. And I mean, that's just what I've seen. So I don't know if anyone else has that experience or not.
All right, thank you very much, Aaron. I really kind of appreciate the fact that you looked at it from kind of enterprise perspective. You know, it depends on your environment, right? I mean, the most I've seen is those people allow data to reside outside the container. First of all, for the ease of updates, and also, how do I say this, management, right? Containers in most cases are not easily malleable, like easily modified. So by allowing your data to rest outside, for those on that team, thinks that it's better that way. Now we have people on opposing team, you know, like Aaron said, it depends on your environment. You know, which group you go with. It depends. It's very use case specific. But most I've seen is, you know, people tend to use data outside the container. All right. So I think we've come to the end of this this session. Thank you guys for coming. Our next one is going to be in California. So it's going to be at Oracle main office. And I can promise you, you know, it should be very, very interesting. For those who live close to Santa Clara, please and please and please come. You know, I work remote, so I mean, I would like to see some faces once in a while. All right, guys. So I will thank you guys for coming. If anyone has any question, please go on our Slack team. And for those who are here in Dallas, you know, it's a lot of us, to put it that way. But thank you guys for being here.
Thank you.
Good job, guys. Thank you very much.
Thank you very much.
All right, thank you.
All right, bye. Respond to these messages on Slack.
Oh,
yes.
Awesome. All right. We are going to jump.
Thank you, guys.
Great job.
Bye.
Thank you.
Yep. Bye-bye.
Thank you. So is anyone a release engineer here, or software developer, or looking into going to release engineering? DevOps? Yeah, I mean, with Kubernetes background. Yeah.